So when we talk about J. Robert Oppenheimer, the popular story usually jumps straight to the politics, right? The tragedy, the security
Or
hearings.
that image of him at the Trinity test, that blinding
Well,
front.
exactly. We focus on the drama, the end of the story, or maybe the conductor right before the music starts.
But, well, if you really dig into the source material, there's just so much more there. A deeper legacy,
Mm.
Not just the conductor, but like the architect of the instrument itself.
Ah, I like that. Architect of the instrument.
Yeah. And our mission today really is to get past that public drama. We want to translate Oppenheimer's big contributions, physics, chemistry, even organization, into this specific grammar we call motion theory, or MT.
Okay, MT. And for you listening, if this framework is new, maybe we need a quick map, just the basics.
Sure. So in motion theory, we basically treat reality itself as structured motion. Everything is patterns, loops, rhythms.
So stability isn't about things being static, sitting still.
Not at all. It's about perfectly maintained motion, these loops with really tight control. And time. Time is just the rate that any given pattern updates itself.
Right. And you mentioned three factors that define this stability: S, R, and C.
Exactly. S is synchronization density, how well the parts of a system stay in phase, moving together. R is leak, that's energy loss, dissipation, things going wrong. And C is coupling, how strongly the different parts are connected and influence each other.
Okay, wait. Let's try and nail that down. Can we force a simple example like a rowing team? How does SRC work there?
Oh, that's a great one. Okay, S is how perfectly their oars hit the water together, exit together. Total phase lock, right?
Got it. Perfect rhythm.
R, the leak, that's energy wasted on bad strokes. Maybe someone gets injured or they have to stop and adjust something. It's inefficiency.
Okay.
And C, coupling. That's the connection strength. Could be the coxswain shouting orders, or just that shared commitment keeping them all locked into the boat's motion. That SRC engine, that drives structure, whether it's people, atoms, or stars.
That clicks. Okay, makes sense. So let's apply this SRC lens to Oppenheimer's career. You said three big movements.
Yeah, three major areas we need to unpack. First, how he clarified matter collapsing, basically foreseeing black holes when motion fails catastrophically.
Okay. Yeah.
Second, how he formalized this idea of separation of scales. That's the famous Born-Oppenheimer concept. Super important.
Separation scales, right?
And third, how he became, well, arguably the century's most famous coherence architect at Los Alamos, building that human machine.
Let's start with collapse then. That 1939 paper with Snyder. What happens when a star's internal push can't fight gravity's pull anymore?
Right, so the sources frame this as the ultimate story of motion failure. In MT terms, the star loses its internal synchronization, its S, across its whole volume.
The internal rhythms just break down.
Exactly, and the gravitational convergence, that inward pull, it just outruns everything. All the opposing forces, all the internal leaks, they don't matter anymore.
But hold on, isn't that just saying gravity wins? I mean, is calling it synchronization failure really adding something new, or is it just a different label?
That's fair. The insight isn't just that gravity wins, it's how it wins. The mode of failure. Once that collapse starts, general relativity kicks in,
Yeah.
And the outcome is this geometric boundary, the event horizon. The
And
structure that's left isn't defined by some weird substance inside. It's defined by how its internal motion gets trapped by space-time geometry itself. It's a coherent failure of geometry under stress.
and the time stuff they predicted, it's just what Snyder said time rates diverge, right?
Yeah, completely mind-bending. To someone far away, the start surface seems to just freeze at the horizon's edge. Forever.
Frozen in time.
But if you were unlucky enough to be on that surface, locally, you'd be falling inwards incredibly fast.
So the horizon is like a communication boundary.
Fundamentally, yes.
Yeah.
A synchronization boundary. Any signal trying to get out is literally moving too slowly relative to the distorted spacetime. It can't keep pace, can't keep its phase lock with the outside universe. Inside, motion is just trapped.
And we actually see echoes of this today, right? With LIGO detecting black hole mergers.
Absolutely. When two black holes merge, the new, bigger one settles down. And the sources say it gives off the specific signal, a spectrum of quasinormal modes.
The ringdown card.
Exactly, like the unique hum or vibration a bell makes when struck. That winging is the fingerprint of the collapsed trapped motion. It tells us the new black hole's size and spin, confirming the geometric collapse idea Oppenheimer worked on.
And just before that, also in 39, he worked with Volkoff on neutron stars, establishing a limit.
The TOV limit, yeah.
Oh.
Building on Tolman's earlier work, they figured out the maximum mass a neutron star can have before, well, before collapse is inevitable.
So above that mass,
Above that critical mass, no stable pattern, No amount of internal synchronization S can possibly hold up against gravity. The structure has to fail, have to collapse further.
That limit basically sets the stage for understanding supernovae, kilonovae, everything astrophysics looks at today involving stellar death.
It frames the whole narrative, yeah.
Okay, let's pivot. Movement number 2. This feels crucial for anyone dealing with complex systems. Separation of scales. The Born-Oppenheimer idea from way back in 1927 with Max Born.
Right. And the problem they faced was just insane complexity. You've got these heavy, slow-moving atomic nuclei and these incredibly light, zippy electrons, solving their motion together. Practically impossible back then.
So the trick was the nuclei are the slow superloops, right? And the electrons are the fast subloops. You just treat the electrons like they adjust instantly.
That's the core of the Born-Oppenheimer idea, exactly. You assume the electron motion is adiabatic, basically instantaneous compared to how sluggishly the nuclei move. The fast electron loop gives you an energy landscape, like a train map, and then you just calculate how the slow nuclei move across that landscape.
And that's why it fits so well with motion theory. It's the master rule for untangling complexity when things happen on vastly different timescales.
It really is. It's probably MT's favorite design rule because it essentially gives scientists permission to solve the problem piece by piece.
Permission to solve. I like that.
You figure out the fast loop's response, its spectrum, based on where the slow loop is. Then you move the slow loop based on the energy landscape that creates.
But surely that approximation breaks down sometimes. I mean, when does this nice separation fail? When do the fast loops start messing with the slow ones unpredictably?
Good question. That's the critical part. The source material is clear. The BO approximation fails when the energies involved become comparable, when the fast and slow motions aren't so separate anymore. The scale gap closes.
The non-adiabatic zones.
Precisely. That's where things can suddenly get unstable, chaotic. The system stops being nicely decoupled and acts like one big, messy loop. You have to treat it all together then.
And this is where it gets really interesting for, well, everyone, right? Because this isn't just about molecules. This BO idea pops up everywhere.
Everywhere you have big differences in timescales.
Like fast neuron spikes in the brain riding on the much slower changes in synapses. Or fast price changes in the economy happening on top of slow infrastructure development.
Right. Or think climate. Fast weather patterns versus the slow crawl of ocean currents and ice sheet changes.
It's this fundamental way of managing complexity, breaking it down.
It lets us model and manage these incredibly complex systems without getting totally bogged down trying to track every single interaction at once. It's like a structural triage. The lesson really is separation of scales is permission to solve.
Amazing. The same kind of structural logic for a molecule, an economy, a collapsing star. It feels like Oppenheimer was tapping into something universal long before we had this MT language for it.
I think so. And actually, before we jump to Los Alamos, there's one more quick theoretical piece. His 1935 work with Phillips on deuteron disintegration.
Okay, deuteron stripping. How does that fit the SRC model?
It's a beautiful little example of what we call coupling engineering. You're actively reorganizing motion.
How so?
Well, a deuteron is just a proton and a neutron stuck together kind of weakly. What Oppenheimer and Phillips realized is that if you shoot this composite particle at a nucleus, it tends to break apart right near the target nucleus because of the strong forces there. The field gradient basically rips it.
Okay, so it breaks up.
And say the neutron gets captured by the target nucleus while the proton flies off. You've used the deuteron's weak binding, its internal structure, to sneak a neutron into the target nucleus in a way that needs much less energy than trying to force a neutron in directly.
So it's not brute force. It's like a clever trick using the projectile's own structure.
Exactly. It's coupling engineering. You're exploiting the composite nature of the deuteron to lower the barrier for the reaction. You reorganize the nuclear motion pathway.
Okay, I need an analogy for that one, it feels like. Like using a two-part tool that breaks on impact to achieve something specific.
Sort of. Imagine trying to get something inside a fortress. Instead of blasting the wall, high energy cost, you send in this specially designed package, the deuteron, that splits right at the wall, letting one part slip inside easily while the other part gets discarded. It's a surgical strike for nuclear reactions.
Got it. Clever. Okay, that brings us neatly to Oppenheimer the conductor. Moving from subatomic motion to human motion, Los Alamos. The sources don't just say he recruited stars, they call him a coherence architect.
Yeah, who tuned the place, turned a desert mesa into this massive, coordinated instrument.
He was basically running the motion theory playbook on an organization.
Pretty much. Engineered for high synchronization, low leak. Maximize the collective output under insane pressure.
So let's break that down with the SRC dashboard. How did he crank up the synchronization, with thousands of brilliant, probably ego-driven specialists?
Radical co-location was key, and intellectual friction by design. He literally forced physicists, chemists, metallurgists, engineers, soldiers to live together, eat together, bump into each other constantly.
Shared chalkboards.
Shared chalkboards were the crucial tech. That's what the sources highlight, making the problem immediate, visible, shared. That became the tuning fork, locking everyone into phase, despite their different backgrounds.
Okay, so high S through force interaction. How did he cut R, the leak? Los Alamos was top secret externally, but internally, information had to fly.
Right, leak isn't just secrets getting out, it's also internal delay. Friction. He slashed that. He created incredibly fast feedback loops.
Cool.
Open seminars, problem conferences, yes, all behind the fences, but open internally. And crucially, data loops that got experimental results back to the theorists almost instantly. Overnight sometimes?
Yep.
Maximum R reduction means minimum delay. If it takes 3 days for data to get across the campus, your organization is leaking time and energy like crazy. Oppenheimer cut that lag dramatically.
And finally, C, shaping the coupling. If this sounds like org charts, who reports to whom?
It is, but it's more dynamic than just static lines on a chart. He shaped coupling by making group leaders act as interfaces, as couplers. Their job was to translate, to ensure the signal, the C, was strong enough to cross between different disciplines.
Impedance matching for ideas.
Exactly. And maybe most importantly, he set crystal clear goal metrics. Things like critical mass calculations, achieving perfect implosion symmetry. These became the universal phase references that the entire huge project synchronized to. The goal itself coupled disparate efforts.
An organization is a cavity for human motion to the boundaries, and it will sing. That's a powerful way to think about it.
It really is. And you see that same skill in how he built up labs after the war. Conversely, the sources suggest the security hearing, stripping his clearance, was effectively a political act of detuning those couplings, forcing his influence, his knowledge, to leak away and dissipate.
That massive coherence achieved at Los Alamos, though, it leads straight to the ethical dimension. Oppenheimer's famous physicists have known sin.
How does MT read that?
It reads like a stark warning about runaway positive feedback in human systems. What happens when you build a machine, a scientific or organizational one, that creates this immense gradient like unprecedented military power?
It starts reorganizing everything around it.
Far beyond the lab. So the ethical task, maybe, isn't just avoiding building these powerful, leakless machines. It's about consciously designing and damping mechanisms. Oversight. Brakes.
So powerful coherence doesn't just export catastrophic leak-like mass destruction onto the world stage without any way to slow it down internally.
Exactly. You need those governors, those feedback controls, built into the system that generates the power. So wrapping this up, what does this whole grammar, this Oppenheimer-inspired way of looking at physics and organizations mean for us now? The sources say his ideas lead to testable predictions today.
They do. It's not just historical analysis. Take collapse identity. Test A. We think a merged black hole is defined purely by its quasinormal modes, its ringdown.
Right.
Okay, well, we can test that. Predict the precise ringdown spectrum for the next LIGO event, maybe even accounting for tiny environmental effects. Then we check the actual data. If it doesn't match, the simple collapse identity theory has a problem.
Falsifiable. Okay. What about test B, scale gap failure, where the Born-Oppenheimer separation breaks down?
Right, those non-adiabatic zones you mentioned. In engineering, this is super relevant. Think about power grids. You have slow human operator responses and incredibly fast electrical oscillations.
A huge scale gap.
Usually. But sometimes they can collide. We can develop a metric for that scale gap and predict where grid blackouts are most likely to occur because the BO-style separation is failing. If that metric predicts failures better than standard models, the principle is validated for engineering safety.
And test D, applying the Los Alamos SRC model to modern projects.
Yeah, organizational coherence. We can set up comparative studies. Take two similar multi-site projects. In one, you actively manage SRC mandatory cross-team seminars, fast feedback reporting systems. In the other, same budget, but looser coupling, slower info flow.
And you predict.
You predict the SRC-aligned project will have a significantly better time-to-result efficiency. If that holds up consistently, Oppenheimer's organizational grammar isn't just history, it's a reliable design principle for today.
It's really striking, this duality in his legacy. On one hand, explaining how coherent matter catastrophically fails collapse, and on the other, how complex matter holds together through separation of scales.
And then layered on top, the masterclass in orchestrating human motion for unprecedented coherence at Los Alamos. The core craft, though, it feels the same underneath it all.
Which is
Raise synchronization, cut the leak, shape the couplings, and always, always watch the scale gaps, whether it's atoms or people.
And that final lesson seems both technical and deeply moral. Powerful coherence needs design damping. It needs brakes, reflection, oversight built in. Because as the source material seems to warn us, without that, convergence can carry a lot more than just matter across horizons. Thank you for taking this deep dive with us today.